This activity is from the linear equations and intercept form section in the book. Bob starts his exercise routine by jogging to the gym. His trainer says this activity burns 215 calories. Bob's workout at the gym is to pedal a stationary bike. This activity burns 3 8/10 calories per minute. How many calories has Bob burned after he's pedaled for 20 minutes, and how long did it take for Bob to burn 443 calories? So let's take a look at the chart here. We've got his pedaling time in minutes as X and the total calories burned as Y. So what is the number of calories that he has burned before he starts pedaling? So if you look at it, you can see that he has already burned 215 calories. Now remember, you can always stop the video and work on the chart or any of the questions, and then you can turn it back on to see if you've gotten the right answer. This will mimic what would be happening in the classroom if you were there. So he's got 215 calories. That's what he's already burned before he even gets on the bike. So it says that he burns 3 8/10 calories per minute. So from here to here, we're going to get plus 3 8/10. So if we just add that, we will have 218.8 calories. After 2 minutes, again, we're going to be adding 3 8/10. We would have 222 6/10. Now notice here we're jumping down to 20 minutes. And that would be 291 calories. How did we get there? We went from 215 to 218 8/10 to 222 6/10 because we simply added 3 8/10. I hope you didn't add 3 8/10 from 2 to 20. What is the equation that we might have had? Think about what you're doing and where you're starting from. What will we get for 30 minutes of pedaling time? Hopefully you would have realized that you have already burned 215 calories, and it is 3 8/10 calories per minute, where X equals the number of minutes. 30 calories would be 329, 45 would be 386, and 60 would be 443. So back to our questions. How many calories has Bob burned after he has pedaled for 20 minutes? 291 calories. And how long did it take for Bob to burn 443 calories? 60 minutes. So he was on the treadmill, or the bike, for an hour. So we have two different types of forms for writing equations. The book talks about intercept form. And the way that they look at intercept form is they write it this way. They write it as y equals my screen keeps flipping here, b plus mx. Okay, so now hopefully the screen is going to stay where it needs to be. So intercept form, this is what the book is writing. Y equals b plus mx, where b is your y-intercept right here. And then we're used to seeing it in this form, slope-intercept form. This is what we typically see in an algebra book, y equals mx plus b. And m is the coefficient, also known as the rate of change, also known as slope. And b is the y-intercept. It's the value of y when x is 0. And the intercept gives the location of the point, 0, b, where the line crosses the y-axis. This is really, really important. So we have our graph here. This is back to Bob's workout. We have time in minutes and calories burned. Identify the b. What is the b value? So in this case, the b value is 215. And what does it mean in context of the equation, in context of the word problem that we're talking about? It means that he burned 215 calories before he started biking. He burned 215 calories before biking. Okay, so now let's take a look at the next question. Identify the m. What is that coefficient in that equation? You see the equation's right here. That is 3 8/10. And what does that mean? It is the amount of calories burned per minute. Okay. Is this a direct variation? What do you think? No. It is not a direct variation because it does not start at 0, 0 here. It meaning the line. It does not start at the origin. In this equation here, we have a Mini Cooper. It's 220 miles from its destination, which is Flint, Michigan. It began traveling toward Flint at an average speed of 72 miles per hour. Where will the Mini Cooper be after 2.5 hours? And when will the car be 130 miles from Flint? Okay, so it's 220 miles from its destination. So we should have adjusted our scales on our graph in class. So we have, it is 220 miles from its destination. So there's your 220 miles. So I am going to say that Flint, Michigan, this is my destination right here along this x-axis. It's got your hours, but this is where our line's going to be drawn. It began traveling toward Flint at an average speed of 72 miles an hour. So if we have to get from here to there, okay, the line's going to be going down. So what's happening with our speed, our destination? What are we starting with? Where is that starting point that we are going to have as far as our b, our y-intercept? Because we know we need to have a y equals. So I'm looking at 220. And we're going 72 miles an hour. So I'm going to have x equal the number of hours. But are we going to be adding or subtracting? If our line is going down and we are wanting to take away the mileage from where we started, we are going to have to subtract. So we're going to have 220 minus 72x, where x is the number of hours. So where will the car be after 2.5 hours? So we need to take this 2.5 hours and put that in for x. So we are going to have 220 minus 72 times 2.5. And that would give you 220 minus 180. And that's going to give you 40. So the Mini Cooper is 40 miles from Flint after 2.5 hours. So it looks like it's right there. 2.5 hours, 40 miles from Flint. When will the car be 130 miles from Flint? So 130 miles will be on your y-axis. So we're going to do 130 equals 220 minus 72 times x. You're going to subtract 220 from both sides, and you will end up with negative 90 equals negative 72x. Divide by negative 72, and we have 1 1/4 hours. So in 1 1/4 hours, it's going to be 130 miles from Flint. So 1 1/4, 130. So it looks like 130 miles, 1.25. Looks like it's going to be right about here. So if we look at our line, looks like our line is kind of coming down. I don't have a ruler. Right around there a little bit. So it looks like, how long does it take approximately to get to Flint? Looks like it's a little bit more than 3 hours. I don't have a ruler. I should be more accurate. So we graphed the relationship, we located the points. What does the real word meaning of the rate of change in this relationship mean? So your rate of change is right here, your negative 72. What does that mean? So that is your 72 miles an hour that you're going. You're heading toward Flint. So this is your velocity, because it is in a particular direction. It's negative, so the car is getting closer to Flint. That's what the sign means, is because it's going away from its destination, and the slope is going down, the rate of change is going down, the line is going down. Go ahead and take a second and figure out what exactly is this mark down here. At what point will the driver be at his destination? And think about what this value should be down here that you're going to plug into your equation. Pause it. You can go ahead and figure that out, and I'll work it out for you. So in order for it to be at its destination, this value has to be, this y value has to be 0. So b 0 is 220, 72x, negative 220 equals negative 72x. And then we have approximately 3 5/5 hours, or time, the hours there. Tomorrow we will take a look at the next couple lessons. Hope you're having a good time.